Hi, it's Alice.
Hey, it's Caitlin. Ginger.
We'll be talking about the
Big Bang Theory. Woohoo!
Okay, so
What is it?
how did it actually happen?
Do we know what actually happened?
And are there conspiracies? Has it got to do with religion?
Well, no one actually knows.
But we're trying to go as close to the truth as we can.
And we'll tell you. Theme song!
Our whole universe was in a hot, dense state that nearly 14 billion years ago expansion started. Wait, the earth began to cool, the autotrophs began to drool, Neanderthals developed tools, we built a wall. We built the pyramids, math, science, history, unraveling the mystery that all started with a big bang. Hey!
Let's put on our thinking cap, shall we?
Okay, so what is the Big Bang Theory? The theory states that originally all the matter in the universe was concentrated into one tiny point. This then began to enlarge rapidly in a hot explosion called the Big Bang. And it happened around about 13.7 billion years ago. However, it's really cool because it's still expanding today.
Okay, so what is Hubble's law? Hubble's law was named after Edwin Hubble. He discovered that galaxies appear to be moving away from us at speeds proportional to their distance. This observation supports the expansion of the universe and suggests that the universe was once compacted. Okay, so CMBR, what does it stand for? Cosmic, microwave, background, radiation. CMBR. So scientists discovered that there are microwaves coming from every direction in space. And this is called the cosmic microwave background radiation, or CMBR for short. CMBR comes from radiation created at the beginning of the universe. The Big Bang Theory is the only theory at the moment that can explain the presence of CMBR. Evidence for the Big Bang Theory. First thing is redshift. Now what is redshift? Well, the sun contains helium. And we know this because there are black lines in the spectrum of the light from the sun, where helium is absorbed. And these lines form the absorption spectrum for helium. Then, when we look at the spectrum of a distant star, we still see an absorption spectrum. However, the pattern of the lines has moved towards the red end of the spectrum, as you can see. So the rule is, the further away from us a star is, the more its light is redshifted. This tells us that galaxies are moving away from us, that the further away a galaxy is, the faster it's moving away. Now, since we can't assume that we have a special place in the universe, this is evidence for a generally expanding universe.
Now we'll be talking about
The Doppler effect.
If I have to, I can demonstrate. Meow.
Hey, what's Sheldon supposed to be?
Oh, he's the Doppler effect.
Yes. It's the apparent change in the frequency of a wave caused by relative motion between the source of the wave and the observer.
Okay, so what is the Doppler effect? Well, let's think of a police car. It's got sirens going on at full blast, and we have two people, person A and person B. Person A is 5 meters away from the police car, and person B is 15 meters away. Now, person A will hear the sirens as being really high-pitched, and person B will hear them as being really low-pitched. There is a change in frequency and wavelength, and we call this a Doppler effect. Let's think of music. If it's going away from the observer, the wavelength increases and the frequency decreases. If it's going towards the observer, the wavelength decreases and the frequency increases. So how do they relate? Well, first of all, there was just energy, then energy and mass, and because of an explosion, all matter was flung apart, and this created the Doppler effect. To start with, the explosion would have been really hot, but then it started to cool down to about negative 270 degrees. At that temperature, protons were able to join with electrons, and this led to the birth of the first stars.
Now, don't I look silly sitting here wearing this?